Hello, everyone. Good evening. Welcome to Ganit. My name is Utsav. I have started this series of video lessons on topics that are in ninth and grade 10th as well. The purpose of creating these lectures is to help you understand different types of relevant questions. And when I say relevant, what I mean is relevant from exams point of view. Today, I'm going to start with exponents. It's a very important chapter, uh, very tricky chapter, very sneaky one. I'm trying my best to explain you every type of question available and relevant from exams perspective. Okay, so without further delay, let me write the first question. So I have this series of questions written with me in my notebook, and I have curated it in such a way that it covers every relevant question. So let's see. The question that I have is this: 25 by 9 to the power negative 3 by 2 divided by 5 by 2 to the power negative 3. What are the fundamentals and the formulas involved? I'm going to make it a habit to write every concept involved in a particular question on the side of the solution itself. Becomes easier for you to take a note of that. So one very important concept involved here is with that of negative exponent. When you have a negative exponent, always remember the base will flip and the exponent will become positive. Remember, the base flips, the exponent does not flip. Exponent becomes positive. It does not flip. So 81 by 16 to the power negative 3 by 4 will become 16 by 81 to the power positive 3 by 4. It will stay as 3 by 4. It won't become 4 by 3. It just becomes positive. Then the second term, 25 by 9 will become 9 by 25 to the power 3 by 2 divided by 5 by 2 will become 2 by 5 to the power positive 3. So whenever you're dealing with a question which has negative exponents, my suggestion to you is सबसे पहला काम ये करिए कि कुछ भी हो जाए हमको एक्सपोनेंट पॉजिटिव चाहिए. That should be your beginning step. A lot of time my students ask, how do we begin a question? If you see a question like this, that's how you begin. Make the exponent positive. Now 16 by 81. Now the second rule involved here is a to the power m whole to the power n can be written as a to the power mn. So if there is an exponent raised to power another exponent, then those two exponents multiply with each other, right? Now, if you see here, if I consider 16 by 81 as an example, and I am seeing that it is raised to the power 3 by 4. So I would want to convert the term inside the bracket in such a way that it has something raised to the power 4. Why? Because let's just say it becomes x to the power 4, and then I have a 3 by 4 here. So 4 and 4 will easily cancel out. Why is it cancelling out? Because the exponents are supposed to be multiplied with each other. So when you multiply 4 and 3 by 4 with each other, the 4 and 4 cancels out. And let's be honest with each other. I think a question with fractional exponents, nobody likes it. So what we need to do is get rid of the fraction. First step, get rid of the negative exponent. Second step, get rid of the fractional exponent. So 16 by 81 can be written as 2 by 3 to the power 4 and then whole to the power 3 by 4 times 9 by 25 similarly can be written as 3 by 5 whole squared to the power 3 by 2 and divided by 2 by 5 to the power 3. Now remember, 2 by 5 is a fraction which has prime numbers. Exponents has a very, very important rule for prime numbers. The moment you see prime numbers, you should know you're pretty much helpless. You can't do anything with a prime number. The only thing you can do is expand it further. 2 by 5 to the power 3. You can't put it raised to the power anything else. 2 is a prime number. 5 is a prime number. Let it be like that. For now at least. 4 and 4 cancels out. You have 2 by 3 to the power 3. You have 3 by 5. So 2 and 2 cancels out. You have 3 by 5 to the power 3. And the division sign will change to multiplication and it will become 5 by 2 to the power 3. Remember, when you are dividing two fractions, x by y divided by a by b, this is something which is very fundamental in nature. I should not be telling you about this, but then again, we are all humans. We're bound to make mistakes. We're bound to forget things, right? So this is how you approach this question. Now I'm dealing with a bunch of numbers which are, all prime. If you see, 2 is prime, 3 is prime, 3 is prime, 5 is prime, 5 is prime, and so is 2, right? So all the numbers are prime. Nothing further can be done. The only thing we can do from here on is simplify the exponents. Now there are two ways to approach it. Either you write 3 by 5 to the power 3 again as 27 by 125 sort of number, or you can do it the way I prefer to do it. Small kids would prefer to do it that way. So 2 into 2 into 2 into 3 into 3 into 3 into 5 into 5 into 5. Everything is raised to the power 3. Might as well just write it 3 times. Let's be honest, let's agree on this. If I have to do some sort of cancellation, I would always prefer the numbers to be in the range of 235 rather than having a 125 to deal with. So that's my preference, right? And it's an easier choice to go ahead with. So we have 3 into 3 into 3, and then we have a 5 into 5 into 5, and then we have a 2 into 2 into 2. If you notice, entire 2 is a set, cancels, 5 5 cancels, 3 3 cancels. You are left with the usual suspect answer, 1. So most of the questions in exponents, I'm not telling you to generalize anything here, but most of the times, the moment you see a very ugly looking big question, the answer is 1 without fail, right? Most of the times at least. So I hope you understood this question and the concepts involved in it. You can take a screenshot if you want, you can note it down, and then we will move on to the second question. I'll try my best to cover as many questions as possible in one single class, but I also want at the same time not to bog you down with too many questions. So I have this another question, something similar what we just did, but with slightly bigger numbers. So 64 by 125 to the power negative 2 over 3. Then we have a plus 4 to the power 0 into 9 to the power 5 by 2 into 3 to the power minus 4. And then minus, you have a root 25. Then we have a cube root of 64. And then we have times 1 by 3 to the power minus 1. First and foremost, when you see a question which has mix of all the different mathematical operations, there's plus, there's minus, there's multiplication, be very careful. Use BODMAS. Treat the terms as one single term. So if you see here, these three are being multiplied. I will solve them together. These two are being multiplied. I'll solve them together. And this is a separate term. I'll solve that separately. And then when I have my answers, I'll club them using BODMAS. So I'll add the positives, subtract the negative. Keep it simple. All right. Again, what we just studied, 64 by 125 to the power negative 2 by 3. First job, make the negative exponents positive. We see quite a few of them here. So what we do, we write 125 over 64 to the power 2 by 3 plus 4 to the power 0. Now, the rules involved, anything to the power 0 is 1. Always remember that. So this is 1. So I don't need to write that. 9 to the power 5 by 2, no negative exponent, so we will let it be. And then 3 to the power minus 4 can be written as 1 by 3 to the power 4. Minus square root of 25, we are all familiar with that, it's 5. Cube root of 64, we know it is 4. And then 1 by 3 to the power minus 1, we'll flip the base, it becomes 3 to the power positive 1. I don't need to write that, right? So now we will solve this. Remember, 3 is in denominator, so try and create a 3 inside the bracket also in the exponent. So 125 can be written as 5 by 4 whole cube, and then to the power 2 by 3. Then plus 9 to the power 5 by 2 is 3 to the power 2 and to the power 5 by 2 into 1 over 81. 3 to the power 4 is not such a big number that you have to let it be as 3 to the power 4. It's an 81. It's a 2-digit number. I think it should be okay for you. It's not very uncomfortable number. So 15 by 4 here, right? So 3 cancels out. We have 5 by 4 to the power 2, which is 25 over 16. We have 2 and 2 cancels. 3 to the power 5 is, if I'm not wrong, 3 to the power 4 is 81, and then 243 times 1 by 81, and minus 15 by 4. Remember, in the beginning I told I'll solve this block separately, this block separately, and this one separately, and then club the results. So time to solve the blocks. 81 will give it, cancel it by 3. So we have 25 over 16, we have a plus 3, and then we have a minus 15 by 4. Simpler thing to do is just take a common LCM, right? So 25, 48, and 15 fours are 60. So if you simplify this, you will get 73 minus 16 minus 60 over 16, sorry, is equals to 13 over 16, and that's your final answer. So remember the things that we learned here. If there are a mix of operations, try and break your question into blocks, solve each block independently, and then club their results. Okay, I hope what you saw on your whiteboard is okay for you. You understood everything. Now we will move to the next question, next type of question. So again, a very popular type, 5 to the power n plus 3 minus 6 times 5 to the power n plus 1 whole upon 9 times 5 to the power n minus 2 square times 5 to the power n. So, look, exponents, I understand it's a very arithmetic sort of chapter, but it has its own share of algebra. Let's be honest. Yeah, I mean, there is so much algebra involved in exponents, especially the proving questions, which will come later. We'll talk about that as well. So, whenever you talk about algebra, a few things come naturally. A few things are there which just goes without saying. Taking common, right? If you see something repeating itself, assuming it as a simpler variable, there are some small hacks which can help you solve a big question pretty easily. Okay, but the most important part of this question is understanding the fact that the laws of exponents that you learn can be applied both directions. So if I have x to the power m times x to the power n, I can write it as x to the power m plus n. But I can write x to the power m plus n as x to the power m times x to the power n as well. So the problem is that if I ask you 2 to the power 3 times 2 to the power 5, you'll very easily say it is 2 to the power 8. Or if I say 2 to the power 3 times 2 to the power x, you'll very easily say 2 to the power 3 plus x. There is no rocket science involved here. I mean, it's very easy. Why are you asking this question? But if I have 2 to the power 3 plus x, would you be able to decode it like this? That it is 2 to the power 3 times 2 to the power x. That's where the question is. So if you pay attention in the question, you'll see 5 to the power n plus 1. Now, I won't ask you what is 5 to the power n plus 1. What I will ask you is what is 5 to the power n times 5 to the power 1. You will immediately say it's 5 to the power n plus 1. Then, if you have 5 to the power n plus 1 in a question, why can't you write it like this? That's the most important aspect of this question. So you have to understand 5 to the power n plus 1 can very easily, very conveniently be written as 5 to the power n times 5. Let's do that. So 5 to the power n times 5 to the power 3 minus 6 into 5 to the power n times 5 to the power 1 whole upon 9 times 5 to the power n and minus 4 times 5 to the power n. So if you notice, 5 to the power n is present in all four terms. So what we are going to do, we are going to say let 5 to the power n be p. Replace it with a simpler variable. There is no rule against it. What you're doing is you are using your head. Probably might not be appreciated by your school, might not be appreciated by your classmates, but you're still using your brain, right? And using your brain, you should get full marks. So do that, right? 5 to the power n is equals to p. So what I'm doing is I will replace it with p. 5 to the power 3 minus 6 times p times 5 whole upon 9 times p and minus 4 times p. If you notice, you'll see how I changed this multiplication sign to a dot the moment I move to the next step. Remember, it's very important. I want to say this. So if you have a multiplication sign, especially in questions where algebra is involved, be very careful. You can very easily understand or misunderstand that multiplication sign for x, and that can complicate the whole question. Very, very important. If you have some involvement of algebra in any situation, please use dot as a symbol of product. Do not use cross. Okay, now we will simplify this further. So p times 5 to the power 3 becomes 125p minus 30p whole upon 9p minus 4p. So if we solve this further, what do we get? 95p over 5p. I will just cancel out p and I will cancel out 5 and 95. That gives me 19, and that's your answer. Now, I want you all to really pay attention to one small thing. I have a small request. Whatever methods you are learning, whatever methods you're practicing, everything is fine. Everything is fine. Please understand, I am not asking you to prefer a given method. What I'm asking you is be smart. Think what comes to you naturally. Think if something is being discussed in this class, can you actually replace it with the approach that you have been following so far? Because the whole purpose of me taking these classes, first, I want to take it. I love that. Okay. The second thing is to make your life easier with small, small approaches which were lying right in front of you. Probably you didn't pay attention. That's all. All right. So I will close the session with these three questions. Very important. Based on these three questions, please try as many questions as you can, and we'll catch up in the next slide on exponents itself.